discuss the continuity of the following functions. The first one, f of x equals 1 over x minus 5, so something like that. And you're better off just drawing a little sketch. It's quite a simple one to draw. If you think about what 1 over x looks like, so say I had a g of x equal to 1 over x, you should know, hopefully, that kind of looks like that. It's got a vertical asymptote at x equals 0, and then everywhere else, when you divide by 1, you get 1. When you divide by minus 1, you get minus 1. And then if you divide by numbers in between 1 and 0, you get a very large number, or if it's negative, you get a very large negative number. If you divide by numbers bigger than 1, you get numbers smaller than 1, and getting smaller and smaller and smaller. And if it's negative, it happens, but it's negative, right? So say I want to draw 1 over x minus 5. So f of x, we're saying, equals 1 over x minus 5. So that's the same as g of x minus 5. So it's like doing the same thing as it function-wise, as in taking the reciprocal of something, but the something you're taking a reciprocal of is x minus 5. So we're changing the argument, which means it's the transformation. It goes 5 units to the right, and it doesn't move up at all. So f of x is going to have its horizontal asymptote. Rather than being at x equals 0, it's going to be at x equals 5. So if we draw the asymptote first, it should be easy. That's x equals 5. And then everything else, it's going to be the same. So it's still going to, go up to this asymptote here. It's going to go down, and then it's going to go along here on its horizontal asymptote, which is not going to move because this was just a horizontal movement. And then we're going to do the same thing over here, down quite steeply. And then it's going to go over here. Right, so that is f of x equals 1 over x minus 5. So once you've got the graph, to think about the continuity, well, remember, a function is classed as being having continuity, or being continuous, if at any point on it, or just pick a point on it. First off is if the function defines. If I pick a point here, is the function defined? Yes. And the limit of the function, when I come from both directions, does it exist, and secondly, is it equal to the value of the function? So if I just pick a random point here, you can see yes, it's defined. If I go here, the limit as I zero in on this place would be equal to that, and it would be equal going the other way. And that's the case everywhere, apart from where we've got this problem. We've got this hole in the function, discontinuity. So this is where x equals 5, right? So where x equals 5, we have a massive problem with regard to continuity. So firstly, f of x is not defined, or is undefined when x equals 5. So that's the first problem, which means definitely discontinuous. But then we need to decide, well, is it a removable discontinuity, or is it an essential discontinuity? Now, the way we work this out, or the way we determine this, is, well, does the limit exist? So if we move towards 5 in this direction, the closer and closer x gets to 5, we're going towards minus infinity. So already that on its own is enough to tell you that the limit of f of x as x approaches 5 doesn't exist. If we go the other way, it approaches positive infinity. So if you're approaching infinity, the limit doesn't exist anyway. But even if we were approaching a finite thing, well, we're not approaching the same finite thing from the two directions, as in from the left and from the right. So definitely doesn't exist, which means that at this point where x equals 5, the function is not continuous, and it is an essential discontinuity because the limit of f of x as x equals 5 does not exist. So the lim of f of x as x approaches 5, and this is in both directions, dne. So if the limit doesn't exist, that means the function has an essential discontinuity. F of x has an essential discontinuity at x equals 5. But as you can see, it is continuous everywhere else. So f of x is continuous for all xer, for all real x apart from 5. And at x equals 5, we have an essential discontinuity because the limit of f of x as x approaches 5 does not exist. If that limit did exist, then potentially we could have a removable discontinuity. Right, the second function we need to look at, b, is this interesting piecewise one. So you've got f of x equals 1 when x is greater than or equal to 0, and it equals minus 1 when x is less than 0. So that's an interesting type of function, possibly one you've never seen before. Let's try and graph it. It's x and y. So we are told that f of x equals 1 when x is greater than or equal to 0. So when x equals 0, f of x is 1. So we can include this 1 here. And then when it's greater than 0, well, it's still 1. So all the way in this direction is going to keep going on. It's basically the graph of y equals 1. Now, when x is less than 0, f of x equals minus 1. So you can kind of go to minus 1 and you can draw this. So it's you can have an open symbol there. It excludes minus 1 and it kind of goes that way. And that's at minus 1. So it's an interesting function. So if x is anything less than 0, y is minus 1. If x is 0 or more, y is 1. So that's what the function looks like. Very funny looking thing. But as far as being continuous, well, remember, to be continuous at a point x equals a, firstly f of a needs to be defined. Right, and actually f of a is defined everywhere. So the only place where you'd have a doubt is when a equals 0. But it does say clearly when a equals 0, f of a is 1 because this bit's included, this bit's excluded. So that's defined. But the problem there is that the limit doesn't exist. So if we just look at the limit as x approaches 0, well, let's have a look from both sides. So the limit as x approaches 0 from the left hand side of f of x, this is f of x. Well, you can see we approach 0 this way, it's clearly minus 1. The lim as x approaches 0 from the other side, well, if we approach from this way, we're approaching 1. So that means that that limit doesn't exist because it's not approaching the same thing. Therefore, the limit as x approaches 0 of f of x does not exist. So even though f of 0 is defined, the limit as x approaches 0 of f of x does not exist. So we've got an essential discontinuity at x equals 0, but everywhere else, you can pick anywhere else on that graph, the limit from, so let's just pick a point here, for example, the limit is from both directions of that function is approaching 1, and it's defined to be 1. You won't find anywhere else on that graph where that doesn't work apart from 0. So f of x is continuous for all real x apart from 0, and here we have an essential discontinuity. essential discontinuity. At x equals 0.